Section 5.5 is on the triangle inequality. The triangle inequality theorem says that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. In other words, pick any two sides of the triangle, add them up, that number must be greater than the length of the third side. And you do have to check every possible combination. So AB plus BC must be greater than AC, AB plus AC must be greater than BC, and BC plus AC must be greater than AB. So let's take a look at a couple examples here. So is it possible to form a triangle with the given side lengths? In other words, we have to do all possible combinations of two sides added together, and that has to be greater than the third side. So is 15 plus 16 greater than 30? Is 15 plus 30 greater than 16? And is 16 plus 30 greater than 15? So we have to try all possible combinations. So let's check each one of these. So 31 is greater than 30. 45 is greater than 16. And 46 is greater than 15. So if you pick any two sides and add them up, it will always be greater than the third side. So yes, it is possible to have a triangle with sides of 15, 16, and 30. Let's take a look at example 2 here. Is it possible to have a triangle with sides of 2 feet, 8 feet, and 11 feet? Is 2 plus 8 greater than 11? Well, actually, I think I'm going to stop right there. No. 10 is not greater than 11. And since that one doesn't work, I don't even have to try the other possible sides. So no, it is not possible to have a triangle with sides length of 2 feet, 8 feet, and 11 feet. This problem says find the range for the measure of the third side of a triangle given the measures of the two sides. So if I have a triangle that has one side that's 4 inches, one side that's 8 inches, how long and how short can the third side be? So I'm going to start by saying let x equal the third side of the triangle. So that means 4 plus 8 has to be greater than the third side. 4 plus the unknown side has to be greater than 8. And 8 plus the third side has to be greater than 4. So let's figure out what all of those have to be. So 12 has to be greater than x, or let's write that as kind of a traditional inequality with the x on the left. So x has to be less than 12, x has to be greater than 4, and x has to be greater than negative 4. Now we need to put all of these inequalities together into one statement, and the easiest way that I've found to do that is to graph each of these on a number line, which really isn't too difficult. I'm going to start it a little bit lower here. And I need to put those three numbers on there, negative 4, 4, and 12, and it doesn't really matter as long as you get them in the right order. So my first inequality says x has to be less than 12. So there's a graph of x is less than 12. X has to be greater than 4. Here's a graph of x is greater than 4. And x has to be greater than negative 4. There's a graph of x is greater than negative 4. Now I need the region where all three of those inequalities are true, and that would be right in between here. So all three of those inequalities are true when x is greater than 4 and less than 12. So the way I write that is x has to be between, but not including, 4 and 12. So x can be any number between 4 and 12. It can be 4.0001, and it can be 11.99999. Here's another example. So if I have one side of a triangle that's a half foot, the other side that's 3 1/4 feet, what is the third side going to be? So I'm going to let x equal the third side, and I do the same thing I did before. 1/2 plus 3 1/4 has to be greater than x. 1/2 plus x has to be greater than 3 1/4, and 3 1/4 plus x has to be greater than 1/2. And I'll just solve each one of those inequalities. So this is going to be 3 3/4. Why did I put 0 there? That's got to be an x. Sorry about that. 3 3/4 is greater than x, or flipping it around, x is less than 3 3/4. X is greater than 2 3/4. And x is greater than negative 2 3/4. And to see where those all kind of overlap each other, let's graph that on a number line. So I have negative 2 3/4 here, 2 3/4, and 3 3/4. So x has to be less than 3 3/4, greater than 2 3/4, and greater than negative 2 3/4. So the region where all three inequalities kind of overlap is right in here. So x has to be some value greater than 2 3/4 and less than 3 3/4. And here's how we write the inequality. X is between, but not including, 2 3/4 and 3 3/4. So given this triangle here, let's determine the possible values of x. So I actually need to write 3 inequalities using all 3 of these sides. So remember, AC plus AB must be greater than BC, and so on for every possibility. So x plus 5 plus 2x plus 22 must be greater than 5x minus 7. And I've actually given myself some extra space here to work. Let me write the other inequalities down here. Which ones did I do? I did the top 2. Okay. And x plus 5 plus 5x minus 7 must be greater than 2x plus 22. And I need to do 2x plus 22 plus 5x minus 7 has to be greater than x plus 5. Let's see, did I get all those right? So the top 2 have to be greater than the small bottom one. The right and the bottom are, sorry, the left and the bottom are greater than the right, and the right and the bottom are greater than the left. Okay, so let's solve each one of those inequalities for x. So 3x plus 27 is greater than 5x minus 7, or 2x and 34. So 17 is greater than x, or x is less than 17. There's one that I want to worry about. And 6x minus 2 is greater than 2x plus 22. 4x is greater than 24. Or x is greater than 6. There's another one I want to deal with graphing. And 7x plus 15 is greater than x plus 5. Or 6x is greater than negative 10, or x is greater than negative 5/3. Okay, so let's graph each one of those on a number line. And so I need a number line that needs negative 5/3, a 6, and a 17. So going back to my first inequality, x is less than 17. It looks like this. X is greater than 6. and x is greater than negative 5/3, and the region where they overlap each other is right in here. So x has to be some value between 6 and 17. This example says find the range of the possible values of x if each set of expressions represents the measures of the sides of the triangle. So same idea, pick any two sides, and they have to add up to be greater than the third side. So x plus 1 plus 5 has to be greater than 7. X plus 1 plus 7 has to be greater than 5. And 5 plus 7 has to be greater than x plus 1. So x plus 6 is greater than 7, or x is greater than 1. X plus 8 is greater than 5, so x is greater than negative 3. And 12 is greater than x plus 1, or 11 is greater than x, or x is less than 11. So let's graph all three of those. Negative 3, 1, and 11. X is greater than 1. X is greater than negative 3. And x is less than 11. And all three of those inequalities overlap between 1 and 11. So x has to be a number between 1 and 11. And our last example, if the three sides of the triangle are x plus 2, x plus 4, and x plus 6, then x plus 2 plus x plus 4 is greater than x plus 6. X plus 2 plus x plus 6 is greater than x plus 4. And x plus 4 plus x plus 6 is greater than x plus 2. 2x plus 6 is greater than x plus 6. X is greater than 0. 2x plus 8 is greater than x plus 4, or x is greater than negative 4. Or 2x plus 10 is greater than x plus 2, or x is greater than negative 8. And this one's a little bit different from the ones we had before because we have no less thans here. So we have a negative 8, negative 4, and 0, greater than 0, greater than negative 4, greater than negative 8. So the region where these three all overlap is anywhere where x is greater than 0. So x, in this case, can be any number that's greater than 0. So to summarize, the triangle inequality theorem says that the sum of any two sides of a triangle must be greater than the length of the third side.